Okay, part two. Part two says, well, what's the mean temperature? The mean temperature, the expression for that for a tube is 2 divided by V average times cap R squared times the integral from 0 to R of U as a function of R multiplied by T as a function of R times R dr. All right? So let me start to plug in some things. 2 over V average times cap R squared times now the integral from 0 to R of U as a function of R. Okay, well that happens to be 0.05 times 1 minus R over cap R squared. Okay, times T as a function of R. Well, that's 400 plus 80 times R over cap R squared minus 30 R over cap R cubed, all times R dr. All right? Okay. Well, I just need to solve it. 2 divided by V average times cap R squared. And let me do some multiplying in this integral. Well, I'm going to multiply that final R, this R. I am going to bring it and multiply it by this term here. Okay, start doing the multiplication. In addition, the 0.05 is a constant. I can pull that out. It's multiplying everything. So out front, I'm going to bring the 0.05, okay? And then I'm going to multiply that R in, so that's R minus R squared, R cubed divided by cap R squared, okay? Now I just have left the temperature profile, 400 plus 80 R over cap R squared minus 30 R over cap R cubed. Okay? dr. Now I'm going to have to multiply even all that out. 0.05, the average, cap R squared, the integral from 0 to R. Now I just have to multiply these two things together. And when I do that, I get, this is going to be 400 times R, the first two terms, then plus 80 R cubed over cap R squared minus 30 R to the 4 over cap R cubed minus 400 R cubed over cap R squared minus 80 R to the 5 over cap R to the 4 plus 30 R to the 6 over cap R to the 5. Okay, the integral of all that. Well, now it's pretty easy. Now I just know how to integrate this. So this is equal to 2 times 0.05 over V average cap R squared. Now I'm just going to evaluate that integral. Well, the integral of 400R is 400 times R squared over 2, plus the next term becomes 80 R to the 4 over 4 cap R squared, minus 30 over 5 R to the 5 over cap R to the 3, minus 400 R to the 4 over R times cap R squared, minus 80 over 6 times R to the 6 over cap R to the 4, plus finally 30 times R to the 7 over 7 times cap R to the 5, evaluated between 0 and cap R. Again, the lower limit is very simple because you plug in 0 for all of these terms, you're just going to get 0. So I only need to worry about the upper limit. So let me plug in what the upper limit is. Okay. When I do that, I am going to get, so this is now equal to 2 times 0.05 over the average times cap R squared. Okay. Now times, so everywhere there was a little r, I'm going to have to plug in cap R squared. Oh, cap R, I'm sorry. So I have 400 times cap R squared divided by 2 plus 80 cap R to the 4 over 4 cap r squared minus 30 over 5 cap r to the 5 over cap r to the third minus 400 over 4 cap r to the 4 over cap r squared minus 80 times cap r to the 6 over 6 times cap r to the 4 plus finally 30 times cap r to the 7 over 7 cap r to the 5. All right. So I see, let's look at the second term here. There's a cap r to the 4 over cap r squared. So this is just going to leave me with r cap r squared on top. And that's going to be the same for all the rest of the terms down here. The r cubed is going to leave an r squared on top. This r squared is going to leave an r squared on top. This r to the 4 is going to leave an r squared on top. And this r to the 5 is just going to leave an r squared on the top. All right? So now I see every term inside the brackets has a cap r squared. And out front, I also have a cap r squared. So they're all going to cancel each other. So this cancels with this, cancels with this, cancels with this, cancels with this, this, and this. And what am I left with? Well, I am just left with 2 times 0.05 divided by V average, which was 0.025 times 400 over 2 plus 80 over 4 minus 30 over 5 minus 400 over 4 minus 80 over 6 plus 30 over 7. Punch that through, and I get 419.81, or 420 degrees C.